Okay, I tried to keep that one under 10 minutes. Review, right? Again, you pick a receptor, you go to school, you go to negative selection school. Basically, will you attack yourself? 90% or more fail rate. You actually pass, you become self-tolerant, you're still naive. Now, you're either going to go to the bone, you're going to stay in the bone marrow and go to school, and you're going to go to B lymphocyte school, or you're going to go to the thymus, to T lymphocyte school. Can you bind to an MHC platform? If you can, you become immunocompetent. Let's look at both of these schools. Okay. We already did that. Okay, so you're a naive B. Where are you? You're in the bone marrow, going to school. So you're a naive B cell. You've made it out of school, right? You're going to bind to your antigen. You actually found the antigen. You're going to bind to it. It's very exciting, right? Now you bound to it. You're like, woohoo. Next, you're still naive. You're going to bind to it. And then what are you going to do? You're going to put that on your MHC2 platform, right? You're going to say, look what I did. I did a thing. I'm so proud of myself. Boom. Here you go. It's on your MHC platform. What is that going to do? Helper T. Okay. Right here, we got a helper T cell. Now it's got a receptor. That receptor is going to recognize this on the MHC2 platform. That is going to cause a cascade of chemical reactions, right? Helper T is going to activate this naive B cell. And boom, what do you have? You have a activated B cell. Okay? Your helper T helped your naive B cell after the receptor saw the MHC2. Now you have an activated B cell. What are your options once you're an activated B cell? Two things. You can become two things. You can either become a memory cell or you can become a plasma cell. Basically, this is going to create a bunch of antibodies and this is going to be the memory cell. Okay? This is your B, humoral activated B response. Let's talk about T. Okay, you're a naive T, just graduated from school. I don't know why this will not move somewhere else. I don't know. Okay, so you're a naive T cell. Again, look at this. Look at this action. You have a receptor. Yes, you have a receptor. What happens? You bind to a dendritic cell with an MHC2 platform that has your receptor, that has your antibody on it, that has your antibody on it. Okay? So, what does that cause? Activation. See? And now you are an activated T. Very similar. Let's go back here. Helper T, it binds, it recognizes the MHC, and all of a sudden you have an activated B cell. Okay, activated T cell. Yes, are we seeing how this is working? Now, once you're an activated T cell here, you have three choices. You can become a helper T. Oh, do you see the comparison? Helper Ts. It's almost like they're all one thing. Helper Ts, you can become a helper T cell. You can become a memory T cell. Or what I would choose, obviously, is a killer T cell. Do you remember Joe Cell? I named him Joe. Do you remember Joe Cell who ate something bad and he posted it on his MHC1 platform? He posted it on his Facebook page. He's like, I ate this thing. I was like, it wasn't good, right? What's going to happen? What's going to happen to Joe? Uh-oh. This killer T is just out in your lymph looking for people like Joe who ate something bad. Apoptosis. Apoptosis, friend. He's going to pop holes in you until you die. Sorry, Joe. Sorry, buddy. Okay. Here it is. This is the whole thing in, normal speak. You've got natural killer cells. This is innate immunity. These guys are just going around in your lymph nodes, in your tonsils, in your spleen, recognizing and then responding to stress, right? And they're killing things, right? Natural killer cells. T cells from the bone marrow, thymus, aka go to school in the thymus. Your T cell recognizes its self-antigen and it migrates to the thymus. It goes to negative selection school. It becomes self-tolerant. So it hangs out in the lymph nodes. You graduated school. What happens? It basically produces cytokines and prevents excessive immune response, right? That's your T cell. B cell matures in the bone marrow. Self-tolerant goes to school in the bone marrow, colonizes again in your lymph. Bind to a specific antigen, triggers a cascade of events, which produce plasma cells or memory B cells. I mean, it's basically the same thing. Okay. This was just a reminder of our buddy Joe. This was Joe when he posted on his MHC platform. Here's all of the names of the antibodies. You do not need to know those, but they're there. B and T cells. So here again, we're born in the bone marrow. If we're a B cell, we go to school in the bone marrow. If we're a T cell, we go to school in the thymus. Then we start just hanging out in the lymph nodes until we get activated, right? And sometimes we're in the spleen, sometimes we're in the tonsils. Okay, antigen presenting cells. These are the bridge between systems. You're going to take this, and you're going to take this, and you're going to make one big picture of that. It will be an assignment. I will post it. And you're going to make a big picture of your immune processes there. Your antigen presenting cells are your bridge between your innate and adaptive immune cells, because your antigen presenting cells alert to the presence of pathogens, right? It's like, hey, I ate this thing. Hello. The action of your antigen presenting cells engulf and phagocytose, right? Pac-Man eat, that stuff. And it's going to phagocytose it into smaller peptides and epitopes. And then what is it going to do? What is it going to do after it eats the thing? It's going to post it to Facebook. It's going to post it to Snapchat or whatever. It's MHC. It's going to be like, I ate a thing, right? I ate this thing. It was weird, right? Your MHC presents the antigen on their surface, and then it's going to activate some T cells, right? And then somebody's going to come along and kill it. Here again, phagocytose an antigen, right? It's going to eat it. And then it's going to exocytose it out. And then what is it going to do? It's going to post it on an MHC platform. This looks exactly like my picture, right? Totally the same. We've got helper Ts. Again, 4 classes of T cells in the thymus. So cytotoxic Ts, these carry out the actual attack. Once you have a mature T cell, you also have helper Ts. They promote activities of other immune cells. You have regulatory Ts and you have memory Ts. Okay, they recognize attack. You again have antigen presentation. That is your recognition. You have T cell. You don't need to know this stuff. It does attack, helper Ts attack, and cyto Ts attack. So those are the 2 kinds. You do not need to know all of this. Th1, no. Okay, antigen recognition. Again, here's your antigen. Here's your MHC protein profile. And eventually, right, it's going to bind to some enemy cell. And it's going to be like, oh man, what's happening, until you get some secretion. And then you're going to activate all of the memory Ts and the Bs and the Cs. Okay? Memory T formation, just, again, you're going to make memory Ts from naive Ts after it's activated, okay? You have antigen encounters, antigen presentation, you have clonal secretion, but basically I gave you the overview of that. So here it is, right? You've got antigen recognition. So your receptor recognizes your antigen. This is a lymphocyte, right? This is a B cell, right? It's, oh my goodness, that is a helper T. What is the helper T going to do? It's going to activate that B cell. That's what it does. After the helper T, after these antigen receptors come together. Then, now, what do you have? An activated B cell. You are not naive anymore, my friend. You are a fully activated big boy B cell because of this helper T, because you posted on your MHC2 platform. Right now, you're going to differentiate into a bunch of antibodies, which are going to go out and employ various means to render the antigen harmless, right? So they're like, we're on it, right? These antigens are like, I got you. They're going to secrete antibodies, and they're like, we're gonna attack antigens, right? There's your, basically, it looks exactly like how I drew it. But that is it. And also remember, you're going to make some plasma cells that are going to make antibodies, but you're also going to make some memory B cells. Don't forget about those guys. Some things that these antibodies, these guys, right, from your B, the antibodies, what are they going to do? They're going to neutralize some antigens. They're going to activate complement. Do you remember complement, right? Fever, all that stuff, that's complement. They're going to clump agglutation. Remember when we did A, B, O, we talked about the blood coagulating or clumping, right? That's not good. You don't want to be like that. So it's going to clump those enemy cells, those pathogens. It's going to immobilize them, and then they're going to get phagocytosed. And you're going to get clumped antibodies. So that's what your antibodies are going to do here. That's what these guys are going to do after you've activated your B cell. No, we don't need time. Lymphoid tissue essentially is just going to move all that around. That's what your lymphatic system is for. You've got lymph nodes. Here, I'm sure you looked at it in lab, but here again is what your lymphatic nodes look like in your lymphatic organs. And we did this in lab, so we are not going to redo it, but you have a bunch of nodes here, and this is just the basic anatomy of your lymphoid system. You've got a thymus, you've got red bone marrow, you've got secondary lymph nodes. You've got, here's what a lymph node, it looks kind of like a bean. You've got all of these locations. You labeled this guy in lab, so you're back again, potentially labeling him again. I can see that coming on a test. And you've got, when lymph nodes go terribly wrong, you get edema. And that, my friends, is it for this chapter. Oh, you have tonsils, also part of your lymphatic system. And your spleen. It's Spleen Appreciation Day, let's not forget. The largest lymphoid organ is your spleen. You know I'm going to ask something about the spleen because I love the spleen. So I'm probably going to ask what is the largest lymphoid organ, and that answer to that is the spleen. And it's over there by your diaphragm, kind of above. You should have seen it in class. The functions of the spleen are, again, sort of an erythrocyte graveyard, old fragile red blood cells, macrophages, site of blood production, white pulp. Again, your lymphocytes and your macrophages monitor blood for foreign antigens there. It stabilizes your blood volume. When your spleen ruptures, ruptured spleen requires a splenectomy and leaves the person susceptible to future infections and premature death. When you rupture your spleen, it just like ruptures your blood and you tend to bleed out from your spleen. That's why when your spleen is ruptured, it's bad, obviously, but it's because it fills your body with blood immediately and some other things. Okay, that's it.